Welcome. I am Mr. Clog, the creator of the Arma 3 Object Builder add-on for Blender. In this video, I would like to go over the process to set up and export a basic P3D model. Some of you might recognize this model from the Star Wars game Knights of the Old Republic. This is the recreation of the all too famous Footlocker model from that game. The goal in this video is to create the necessary LODs and set them up in a way that the model will be usable in Arma. A quick note of caution, however, as this video is not a general Blender modeling tutorial video, I will not go into great detail regarding Blendler's usage and the modeling techniques themselves. I will focus purely on the P3D setup and the process necessary for it. To shorten the video a bit and not waste too much time, I went ahead and made a few preparations for the model. Firstly, I created a little scene here in Blender just so we can see what the model actually looks like or supposed to look like. And then I also went ahead and created the necessary PAA textures and the necessary simple RV mat for this model, which we can see here. It is really just a basic super shader, but it will save time as this video is also not a material setup video. I also made a simple model CFG for the lid animation. So with that out of the way, let's see what we'll have to do. The footlocker itself is a very simple model. It is essentially just a crate with a lid that can open. As you can see, there is an interior to this model, so we will try to set up that as well. So thinking ahead, we have the visual model, so we don't have to create that anymore. But it is advised to create lower resolution models for most assets, which we will not do here because that is again a modeling technique, not special to P3D setup. We will create a shadow casting volume, shadow volume LOD. We will create a geometry LOD, which is the collision geometry, a fire geometry, which is the hitbox geometry, a memory LOD for the lid animation, and a roadway LOD to make the box not so much as an obstacle for characters. So let's go ahead and delete everything that we don't need and look at the box. Currently, I have two materials assigned, but I will delete them as we don't really need them right now. And let's see what we'll have to do. The model is already triangulated, so we don't need to worry about that. The lid itself, as we can see, is as a separate object. So the first thing we'll have to do is we'll have to create the selections for the lid animation later on. So the way to do that is to create vertex groups as traditional with Blender. So I will go ahead and select the lid, the little screen on the front of the lid, and also the upper segment of the hinges, and simply create a selection called lid, assign everything to it, and to double check, everything should be assigned. And actually, yeah, I forgot. There are little looking pieces attached to the lid. So let's assign those as well. And then fully everything. Yes, everything is alright. Okay, so selections are all set up with this. This model can now be, once exported, used in model CFG animations. So I will just go ahead and call this visual 1, as this is the first visual LOD. As I said, we will not create the further visual LODs, but they are a rather easy process if you have your own workflow. So the next thing is the creation of a shadow geometry LOD. Well, a shadow volume LOD. I will not make this very complicated. I will just quickly create box, and I will use the inverted box technique in this case because I don't want to model the lid all the way again. So this will be just a very crude, very crude shadow volume for an object like this. Right. Okay, and then let's quickly separate the lid. So the visual one. Okay, so now we have the lid as a separate chunk. Also the bottom half. And now I will go ahead and flip the normals so they are inside out. This way, if we actually turn on backface cooling and turn on the visual LOD, this way the box will cast shadows on the ground, but it won't cast shadows on itself. We don't have to model in all the grooves this way, but this is also a compromise. So this technique is not right for all assets. Right. So let's call this shadow. Actually shadow 1. And then, as you might know, shadow volumes have to be triangulated, so I'll quickly go ahead and triangulate all the faces. And that is it. In order for the animations to work, we'll have to create the same lid selection for the lid of the shadow as well, which is just done. Okay, I actually forgot. We didn't set this up as a LOD object, so this right now is just a model mesh object in Blender. But if we were to go and click on the export model option for Arma, this would not be actually output to the P3D, so we will have to do a bit more setup. If we go down in the mesh data section when a mesh object is selected, there will be a properties panel called LOD properties. If we open this up, we can see that I have already set this as a P3D LOD. By default, this is not set. You will have to do this by hand. Now the type of this is a resolution, because this is a visual LOD, and the resolution index is 1. This is the first one. And then I also went ahead and added previously a LOD no shadow property to it. This is the named properties in Object Builder. The reason for this is to force the game not to try to cast shadows from the visual LOD, but the shadow volume instead that we created. Alright, so now this is set up. Now we will have to do the same setup for the shadow. So we will go to LOD properties, enable, and then find the shadow volume option, and actually the first shadow volume have to be resolution 0, and we will not create a second one which would be resolution 10. So we have the visual and the shadow volume done. Now the next point of order is to create the geometry itself. Sorry, the collision geometry. We will do basically the same process as the shallow LOD. I will quickly create a cube and make it fit our object. Yes, and then bring down on the top. And since the lid can open, we might want to make the geometry animated as well to make it a bit more realistic, especially the fire geometry later. So I will actually just do the same separation as with the shadow LOD. Alright. For geometries, I also like to set them smooth shaded so that I can actually see the separate components to them. And then I will also go ahead and triangulate this LOD as well. And as with the shadow, I will go to the LOD properties, and then I will switch the resolution to geometry and add a auto center 0 property to this. And actually just rename this to geometry as well, if I didn't miss. Yes, okay. Next point is the fire geometry, so I will just go ahead and make a copy of this and call this geometry fire. And basically all the difference will be is that I remove the auto center from this, switch the type to fire geometry, if I can find it, yes. And then I will add a material to this, which will be RV matte pen metal. So we will give it a metal penetration material. Material properties are on the material tab when an actual material is selected, and there will be a tab called Object Builder Material Properties. For penetration materials, we will have to, well, you can either select your own material, but there are a few preset materials as well, so I will just switch to penetration and look for metal if I have it. Probably not. Okay, let's go with plastic then. But we could actually change this, so let's open this up and navigate to metal. There should be a metal plate. Yes, metal plate RV map. Okay, so now the geometry fire is also set up. Let's go ahead and make the roadway, which is also a very simple matter. So I'll just quickly create a plane. And match it to the dimensions of the box. Let's make it go, let's make it go down to the ground and flare out the base so that it forms a nice ramp. This technique is frequently used on box-like assets, so that the so that the characters can walk over them without having to vault or jump, which is by default not even possible in the game. So I will set this to roadway, well, call it roadway, and then I will also jump to the LOD properties, enable this as a LOD, and set it as roadway. Alright. Last piece, the memory LOD itself, very similar to what we did so far. I will create a new box. Basically, there will be 3 memory points we want to create. 2 for the hinge axis and then 1 for the inventory action. So I will merge all the points of this box at the center, go to vertex selection, and I will very quickly move this to the hinges. And I will actually go ahead and make it a proper selection on the actual model so that we get the hinge axis on the center, in the center. Alright, move the point here, and then I will add a mirror modifier and create the selection for the memory points, which will be lid axis in our case. And then finalize assign, apply the modifier, so that will give us the axis. And then I will add in edit mode a new box, merge at the center. Oop, my bad. Word origin, and then merge at cursor, yes. And then let's move this point up to roughly the screen. And also give this a new selection, which will be inventory. Alright, so memory is also created. Let's name this properly. Assign it as a memory LOD. And that's all. Now we have a visual load. Actually, I just forgot a step. The visual load doesn't have its materials, so we'll have to create them. Now, the visual model is supposed to have two materials. The actual color material, if we look at the UV map, has two overlapping pieces. The main part is the actual crate, and then the second part is this little screen on the front. So we'll have to create two selections for these, two materials for these. So I will go ahead and create one RV mat bootlocker. Yes, and then I will also quickly create the second one, RV mat screen. And then on the footlocker, I will go ahead and select the texture and material files that I prepared beforehand. So the texture will be the footlocker CO, and then the material will be the footlocker RV mat. And then on the screen, I will, before I forget, assign the screen itself to the screen material. And I will set the texture to a procedural black color. So we have the visual model set up. It has its materials. It has selection. It has been set up as a LOD resolution 1 with a named property. We have the shadow volume. Shadow, actually, let's just make the naming consistent. So shadow 0 set up as shadow volume as the selection, right? And then that's it. We have the roadway, which is just a simple plane, essentially. We have the memory setup. It has the 3 points we need. Selection setup, load is set up. Geometry, fire geometry. It has the penetration material assigned, set to fire geometry, and then geometry. Alright, so now we have basically the model set up, but some of the LODs, as you probably know, if you've been modding, have certain requirements to them if we want them to work properly. So there is a tool called the validation tool, which can be used to check certain LODs if they match the criteria needed for them to work. So to demonstrate this, let's check the geometry load. I chose this load because I know there is an issue with this and makes a good example. So let's validate this, and it will say that the validation failed, and to check the system console. So we have to open the system console and let's look at the output. So it says starting the validation of the geometry mesh object. The warnings are errors because that's how we launched it. The generic rule set didn't return any errors, so that passed, but the geometry rule set actually returned 2 errors. So it says the mesh has no component selections and the mesh has no vertex masses. And the third is a warning which is related to the second one. So what to do with those? Well, geometry models must have numbered component selections. There is a very easy fix for this. We can click on this Arma 3 object builder icon and click on find components. This will find the components here. The other option is that if we don't have these, we can just also ignore this error here, the no component selections, because the P3D export has an option to automatically generate this. But just to make this unambiguous, let's do the find components. And now the final piece is that we'll have to use the vertex mass editing tool because the geometry components must have some vertex mass assigned to them. Otherwise, the geometry won't work. So we will have to go into edit mode, go to the vertex mass editing, and then let's consider the weight of this piece. So I would say that this box is probably on the base like 2 kilograms, and let's distribute it on all points equally, and then the lid is at most 1 kilogram, so distribute that. And if we click on live editing, we can actually see the individual and selection masses. So the overall mass is 3 kilograms. So now if we run the validation again, you can see the validation passed. If we check again, it says generic pass, geometry pass. The only info is the farthest point, which is just to indicate the geometry limitations. Alright, so we have the geometry. It should be valid. Now let's quickly check on the shadow volume as well, because that also has a few rules. But as you can see, the shadow volume also passed. So now the last step is to actually go ahead and export the model. So for that we'll go to File, Export, Export Model, and name our model whatever we want. Now let's look at these options. So relative path means that the add-on will look at the material and texture paths and also the proxy paths and make them relative to the project root path defined in your add-on preferences. Normally this project root should be just the simple P drive, and then all the paths will be relative to the P drive. The include is there is an option to limit the export only to the selected objects. Otherwise, the export will export all the setup LOD objects visible in the current scene. So just be careful what you export. The mesh data is so apply modifiers means that it will apply all the modifiers assigned to each of the LODs. During export, you don't have to apply them manually. Apply transforms. Now, this is actually an interesting point because if we look at the roadway LOD, the origin of the roadway LOD is not in the center. That means that by default, the roadway LOD would actually export like this because it's also scaled and not in the center. So there are two options for us. We can either apply all the transformations by hand like this, or the export by default has the apply transformations enabled, which means that it applies these transformations during export. We don't have to do by hand. Costume normals is related to the vertex normals, which is another advanced topic for most users, so we'll not get into that. Sort sections is also a more advanced topic. You can read up on that in the documentations. Generate components is the one I talked about for geometry LODs. This will create all the missing components, which will be also handy because I just realized that we did create the components manually for the geometry, but we didn't create the components for geometry fire. So this will generate those during export. There is a collision handling. You might run into an issue where multiple objects in your Blender file are set up as the same LOD and you forget to hide them during export. So you can set what should happen when the export detects this. By default, it will fail. So if you have two objects with the same LOD, it will fail and prompt you to do something. You can ignore and just export the same objects. This might end up causing unwanted behavior in game, or you can set to skip so that the plugin will not export the second LOD with the same signature. Now, the next option is the validate LODs. This is the option to run the validation checks during export forcefully. And what this will do is it will not export any LODs that fail their validations. And then the last options will be the renumber components. This is also useful when you have multiple objects and you forgot to renumber the components from 1 to whatever number you have. Force lowercase simply turns all selection names and paths to lowercase characters to force some uniformity in the output. And then the translate selections is to translate certain frequently used English selections to their frequently used Czech versions. for config compatibility. But usually the default settings are fine. So you go ahead and export, and we can see that 6 slots exported. We can actually look at the export log. Visual 1, Shadow 0, Geometry, Geometry Fire, Roadway, and Memory exported. So let's look at them. Alright, we have the first visual, and then we have the shadow, which looks fine. We have the geometry. We can check that it is indeed 3 kilograms. It has the 2 selections. Memory load also has the 2 points, roadway. And then as you can see, even though we did not create the selections ourselves, but the exporter generated the component selections for us, and we can actually check that the materials are also there. So now all that's left is to check if the model is correct. So let's open up Buldozer and see how we did. Now this is obviously the fire geometry, so let's switch to the visual one. And we can see that we have our box. The textures are assigned as specified by the file paths and the remade. And then we can also check that our animation works. Now, funnily, the animation is backwards, so we will have to quickly check on the model config and reverse the rotation angle and reload Buldozer. Alright, so we have an opening box. We can see that it has some shadows. As I said, this inverted box shadow technique is not suited for all assets. But the box itself works, textures are assigned, and everything looks good. We can also go ahead and, just to be sure, we can validate the convexity, but this is obviously a box, so the convexity should be fine. These are the steps required to set up a model for export, mainly. More videos will go into the tools themselves, and you can read if you click on the question mark icon on the mesh properties. You can open up the documentation, and you can actually read up on everything that's possible. I left out a few more in-depth pieces from the setup. You can also just browse ahead on the documentation page. But since the goal with this project was to create a plugin that as closely mirrors the workings of the Object Builder application as possible, if you know your way around Object Builder, you should have no problems setting up and importing models into the game itself. That's about all I wanted to talk about for this video. Thank you for watching.